So welcome to the video lecture series on theory of computation, and this is Dr.K.N.Sivabalan, and today's video lecture we will be learning about designing a pushdown automata for a problem, specific problem where which is related to a to the power of n and b to the power of n. So here we are supposed to design pushdown automata to accept a specific language where equal number of a's and equal number of b's are there. Okay, so how to design this? First, what we have to do is we have to frame the logic for this. You know that pushdown automata is related to push and pop. So always the number of a's is actually preceding the number of b's in this case. So what we have to do is whenever a is there, we are supposed to push it inside the stack, and whenever b is getting encountered as an input, then we have to pop the a from the stack. So finally you have an epsilon as an input, and we can reach the final state. So the logic is, we'll first design the logic. So the logic is, I hope this is getting clear. Logic is push a's in stack, and when b is encountered, pop a from stack. Okay, so this is the idea behind this. So when your number of a's is actually encountered, then push it inside the stack. When b is actually encountered, pop a from the stack. So this is the idea behind this. First, what we will do is we will just ensure the language which can be accepted by this pushdown automata. So language which can be accepted is L equal to, so I just mention it as a to the power of n, b to the power of n, where n is greater than or equal to 1. So I can say if n is equal to 1, I say that ab should be accepted. If n is equal to 2, bb should be accepted. And if n is equal to 3, triple a and triple b has to be accepted. Okay, so this is the pattern here. So so on and so forth, this kind of language pattern has to be get accepted. So what we have to do now here is we are supposed to write an instantaneous descriptions, and we have to design a diagram for this. So initially I take up a string called as a here, b. Okay, now this is the string, b is the string. So initially what will happen is I just design a stack here. The topmost symbol of the stack is Z0. Okay, now the first input a is actually coming here. Now when topmost symbol of the stack is Z0, a is coming here. Now what you have to do when a is coming here, you have to push it inside the stack. So Z0 a. Okay, so next step, so this a goes off. Next is actually a. Now what is the topmost symbol? Topmost symbol is a here. Now input is a, topmost symbol is a. Again push it inside the stack. So what happens is this a also goes off. Now what is the thing? You have two a's pushed inside the stack and Z0, and now a third a is actually getting the input here. Now if input a symbol is a and topmost symbol of the stack is a again, now you push it inside. Now all three a's are actually pushed inside the stack. So this a also goes off. Now the input is b. So what the logic says? The logic says is whenever you encounter b here, you pop one a from the stack. So now when this b comes here, now I pop one a from the stack. The topmost a gets popped out. Now what will be remaining? A is Z0. Okay. Now this goes off. Now the next b is there. Next b, when next b comes off, what is the topmost symbol? Topmost symbol is again a. Now that also getting popped out. So what will be remaining? A Z0 will be remaining. So this b also goes off. Now the last b. Now one more a is there on the topmost of the stack. Now that also popped out. So what will happen? So this b goes off and topmost a goes off, and now Z0. Now the input is nothing. Input is nothing means that is called as epsilon is the input, and topmost symbol is Z0. If this is the case, then you just make it as accepted. Okay. So now see here, I have a stack trace for this pushdown automata. Now we will draw the diagram for this. So how to draw the diagram for this? Listen here, you can make any number of states. Any number of states here. We have to design the diagram for this. For example, I just make it as Q1 is the initial state. Okay, now how to design this diagram? So initially, what is the input? What is the input? Input is A and topmost symbol is Z0. Okay, so I just move on the same state. Input is A, topmost symbol is Z0. So what should I do? I have to push it inside. Push the A inside is a stack. So it becomes AA Z0. Okay. Now come to the second state. Now the input is A and the topmost symbol is A here. So if that is the case, what should I have to do? I have to push again A inside the stack. That means A becomes AA here. So I just write A. Input is A. Now AA inside the stack. Okay. Now for all A's we have done it. Now I just go to B here. Listen carefully. I just go to B here. If input is B, topmost symbol is A, what should I do? I have to pop it out. So A will get popped out and just I go to the state called as Q2. Okay. In Q2, you can see that this is not only one B, you can have any number of B. So just make a hold here, loop here. B, input is A, pop it out. Okay. And finally, you can see here when you are getting epsilon as an input and topmost symbol is Z0, then you have to accept it. So I just make a final state called as Q3. And you just make it as epsilon Z0. So pop that Z0 and then go to the final state. Okay. So this is the diagram for pushdown automata. Now we will just write down the instantaneous description. So whatever the transitions we have encountered in the diagram, so that is going to be the instantaneous description. So I will just write the instantaneous description, shortly written as instantaneous descriptions. So what is instantaneous descriptions? In this case, you are supposed to write all these transitions one by one. So initially you have the state called as Q1. So delta of Q1 and the input is A, topmost symbol is Z0. Topmost symbol is Z0 means then after the transition it should be A Z0, isn't it? Where it should go? It should go to the same state called as Q1. So I just write Q1 A Z0. Okay. Now the next transition is input is A, topmost symbol is A, and then you have to, after the transition it should be AA. Now again Q1, input is A, topmost symbol is A. You just go to Q1 and write AA. No changes. Now what is the third transition? So third transition is when input is B, topmost symbol is A, you have to pop it out and you are in the state, moving from the state Q1 to Q2. So in Q1, if input is B, topmost symbol is A, you just move to Q2 epsilon. That's it. Okay. Now what is the next transition that takes place in Q2? So in Q2, delta of Q2 comma B comma A, and you are going to same state called as Q2 epsilon. Okay. And the last transition is this one. This one, what is the last transition? Epsilon, topmost symbol is Z0 and then replaced by Z0. So I just write it as Q2 epsilon Z0. Then you just make it as go to the state called as Q3 and Z0. Q3 epsilon. That means Z0 is replaced by epsilon and Q3 is called as a final state here. So that's all about instantaneous description. So once you design a pushdown automata, so it is not only confined to that area. You have to take up one valid string and you prove that your pushdown automata is getting accepted, accepting that corresponding valid string. So that part is called a simulation. So simulation. So how to perform simulation? Now you see what is the initial state here. The initial state is actually Q1. Okay. Now I take up a valid string here. So I take up a valid string called as AABB. Okay. Obviously this is called as a valid string. Okay. Now I have to accept it, or if this valid string is getting accepted, then you have designed a push-down automata in the right manner. Now delta of Q1, input is AABB, and the topmost symbol is Z0. Okay. Now in Q1, what is the input? Input is, you have applied the whole string here. Whole string you have applied. You have to read the inputs from left to right. So when you read the input from left to right, the first input is A, and the input state is actually Q1, and the topmost symbol is Z0. Now A is the input symbol, Q1 is the input state, whereas topmost symbol is actually Z0. What you have to do? Okay, so you just see whether any kind of transition exists for this corresponding inputs. Yes, in Q1, if A is the input and topmost symbol is Z0. So what is the transition you are going to make? It is actually A, Z0, then push A inside the stack, isn't it? Okay, so what you have to do? You have to stay in the same state called as Q1. If input is A, then this A goes off, and what will be remaining? ABB. So this A is getting pushed inside the stack, isn't it? That's it. Now input is A, topmost symbol is again A. What should I do? I have to stay in the same state called as Q1. That's what the transition says. So I just put like this. It's not equal to. It's continuation symbol. Now delta of, I again stand in Q1, and what will be remaining? BB. Again that A is pushed inside the stack, so A is not. Now input is B, topmost symbol is A. What should I do? I have to pop A from the stack. So where I have to go? I have to go to the state called as Q2. So delta of Q2. So input is B, topmost symbol is A. So A is getting popped out. A is getting popped out. So if this A is getting popped out, what will be remaining? It is A is not. Okay. So now in this case, now the input is B, isn't it? Input is B, topmost symbol is again A. What should I do? I have to pop this A out. So you stand in the same state called as delta of Q2, and if this B goes off, so you have epsilon, and if that A goes off, you have Z0. Now we have attained a situation where supposed to go to the final state. Okay, the input is epsilon because no other input exists now, epsilon, and the topmost symbol is Z0. So if this transition, if this condition exists, then you have to go to the final state. The final state is actually Q3. So since you're going to the final state, you can directly write Q3. No need for delta transition because that is going to be the end of the transition. So input is epsilon, and Z0 is getting replaced by epsilon. That's all. Okay. Since you are reaching the final state Q3, that means it is accepted. Okay. So that's all about designing a push-down automata for a specific problem. Thanks for watching a video. Have a good day. Thank you and Jai Hind. Bye.